Guys, welcome back to my YouTube channel. Today I want to talk about the sum and the difference trig identity. So I will start by writing the general forms for the sum of the sine and sum of the cosine, and then we will start looking at some examples. Okay, so guys, it would make more sense for us to actually do one example per video because I don't want to create like huge videos, so I'm going to try to keep it one example per video. Okay, so before we get started, guys, I'm going to start by writing the sum of sine and the sum of the cosine identities. Guys, there's a sum of the tangent identity as well. I'm not going to write it, but if we have to simplify something which involves tangent, we are going to use the idea that the tangent is nothing but the ratio of sine over cosine, and I will show you that when we actually do an example on tangent. Okay, so if you do not remember the sine, the sum of the sine and sum of the cosine identities right now, it is totally fine. You can still keep on using the formula sheet. Okay, guys, if you don't have one, please go online and pull out a formula sheet, print it for your references. Okay, so let's start by writing the sum and the formula. So guys, here I'm going to write the sum formula. So first let me start with the sine of the sum. So sine of A, and I'm going to do both at once, sine of the sum and sine of the difference. Guys, since I don't have too much space here, so I'm trying to write both at once. So the first formula, you will see there's a plus and minus. So first one will be plus and the second one will be minus. So sine of the sum is sine of A, and then I will have the cosine of B, sine of A times the cosine of B, sine of the first angle times the cosine of the second angle, and plus minus here will stay as plus. If it is sine A plus B, then it would be plus. If it is A minus B, then you will use the second one, which is the minus. Okay, and then the next term will be sine A cosine B plus minus cosine A and then sine B. Okay, so guys, this is the sine, sum of the sine. Okay, and then we have the cosine of this A plus and minus B. Please look at the cosine one carefully. Again, I'm not saying you have to remember this whole thing, but it's slightly different than the sine one. So the cosine one looks like this. Cosine of A plus minus B is cosine A. The second term is cosine B. So here it's sine A, cosine B. Here we have cosine and cosine together. And then the most important piece is like here the signs switch, it's minus and plus. What does that mean? That means if you are doing the cosine of the sum, cosine of A plus B, then the formula will be cosine A cosine B minus. Okay, and if you are doing the cosine of the difference, then there will be a plus. Okay, that's what that means. And then I have sine A, and then I have sine B. Obviously we know that this is the product. There's the product as well. And guys, I'm not going to write the tangent piece here, but I'm going to write the third thing that we would need in order to actually simplify this sum and the difference identities. That is going to be the unit circle. Again, I don't have a unit circle right here. That's something that you can find from your textbooks, or again, usually I get my unit circle from online, so I just print out my unit circle. So there's the unit circle. Guys, usually for me, I already kind of remember the sine and cosine up to 90 degrees, and the other ones I can find based on that. Okay, so that is also based on the trig identities. So let us start with the first example. Guys, the first example that I want to do is we want to simplify sine of pi over 12. Simplify as using sum and differences. Okay, simplify using sum or the differences. So we are only going to use this process of using the sum and the difference formulas when the problem actually specifies that you have to use the sum or the difference. Guys, if it does not specify use the sum or the difference, then you can probably just use the unit circle. If you can directly use the unit circle to figure out the value for a particular sine or cosine or tangent, or one can always use the calculator to do that. Okay, but here it says use the sum and the difference, so we are going to actually go ahead and use the formulas. Okay, so the first example, I think I'm probably going to show you like 3 or 4 examples involving this type where you simplify using sum and differences, and there is other types which I'm going to do in other videos as well. There's some different types that we can do for sums and the differences. Okay, so the first one we want to do is we want to simplify sine of pi over 12. Okay, that's what we want to simplify using the sum and the difference. So guys, the first thing that I would like everyone to do is, instead of working with the radians, it is easier for us to, probably for everyone, to work with the degree measures. And we already know that there is the two most common ways of measuring an angle that we use in the trig sections and trig courses is the degrees or the radians. So this is in radians. So the first thing that we would like to do is we want to convert it into degrees. Guys, that's a very simple process. You take that measure in radians, you multiply by a factor which is 180 over pi. Okay, because we know 180 degrees equal to pi radians. That's how we get that factor, and we multiply any radian measure by 180 over pi, and we get the equivalent degree measure. Okay, so let's first do that. So it's like on the side, I'm going to first convert this radian measure into degree. So that can simply be done by doing pi over 12 times 180 over pi. That is the ratio that you multiply to convert from radians to degree. If it is degrees, if it is the other way, degrees to radian, then it is pi over 180. So I'm sure you already know that. Now we cross out, the pi's will cross out, so it's simply 180 divided by 12. 180 can be, let's see if we, if it completely divides by 12, so it is 12. You can use a calculator if you like at this point. So I'm not going to use a calculator. I think we can do it without using a calculator. So it comes out to be 15. Yeah, it's 15. So that means what we are trying to figure out is the sine of 15 degrees. That's the first step that I would like you guys to do, convert from radians to degrees. Once we have it in degrees, now we go back and see what it says. It says you want to use the sum or the difference. You're free to use sum or difference. So what I'm going to do here is I'm going to use the difference. Guys, keep in mind, it's not that you want to come up with any difference or sum of any two angles. Guys, that's why I put a unit circle here. We want to use those angles as sum or difference who we can directly identify or see on a unit circle. So what are the angles that we usually see on the unit circle? It starts with 0, then it's 30 degrees, 45 degrees, 60 degrees, 90 degrees, and it just keeps on increasing from there, right? So the basic ones are those four, 0, 30, 45, 60 and 90. Okay, so based on those numbers, and there's more if you go across the unit circle up to 360, right? There's more. So you are allowed to choose any two angles whose sum or difference gives you 15, as long as they are on the unit circle. The thing is that you have to have the formula sheet in front of you, which has the sum and the difference formulas, which you can see right here as well. And then you also have to have the unit circle in front of you, so that you can, from the unit circle, you can identify which two angles you want to use. So the two angles that I would like to use here, and you may want to use some other angles, guys, the final answer should still be the same. So the two angles that I'm going to use are going to be, and keep in mind I want a 15 degrees, so I'm going to use 45 and minus 30, because 45 minus 30 is 15, and 45 and 30 both are on the unit circle. So we already know what is the sine and cosine of these angles, right? That's the reason why we chose those two angles. Now, once we have the sign of the difference, then we go back here to the formula sheet, or here in this case, I already have the formula written out. We're going to use the formula and write it out. That's what it says when it says, well, that's what it means when it says simplify using the sum or the differences, okay? So this is going to look like sine of 45, and then cosine of B, and then cosine of 30 degrees. Then there's a minus here. If there's a minus here, this is consistent. I also have to put a minus here. And then the next terms will be cosine of 45. Actually, the sum and the difference formulas are pretty easy to remember because you just look at, there's a pattern going on here. So, I mean, you can easily remember these things. Then the next term is cosine of 45, and then there is the sine of 30. Guys, I simply use this, okay? If there's a plus here, I got to use the plus. If there's a minus, then I got to use the minus. Here I have the difference, so I use the minus here. Now you have to, from here, you just have to simplify this. But how can you simplify? Either you have to remember, you should know like what is the sine and cosine of these angles, or you can go back and look at the unit circle. Okay, so guys, if you don't remember these values, then please go back to the unit circle. I think I remember some of these, so I'm going to try and write them. Sine 45 is radical 2 over 2. Then I have cosine of 30. Cosine of 30 is radical 3 over 2. Guys, since I have been doing it for a while, so I remember these values, and I mean, there's nothing really like special about it. If you work on something or if you use something for a while, then you start kind of remembering some of the things, okay? Then cosine of 45 is also radical 2 over 2, because I know that the sine of 45 and cosine of 45 are the same, and then sine of 30 is 1 over 2. Again, that is something I remember. Now we try to simplify this further, guys. Let's see how far we can go. Radical 2 times radical 3, we can multiply them because both have the square roots, right? So that will become radical 6, and 2 times 2 in the denominator becomes 4, minus radical 2 times 1 is just simply radical 2, right? Multiplying by 1 does not change the quantity. And downstairs I have 2 times 2, which is 4. I think we are done, right? We can leave it like this, or if you like, you can also write it like this. Radical 6 minus radical 2 over 4. Usually people prefer to use this as the final answer, simplified answer, but I mean, this is also fine. What we basically did from here to here was like the both have a common denominator. So when they have a common denominator, we are allowed to combine the numerators. And guys, this is the best we can do, because keep in mind the radical 6 cannot be simplified any further, because radical 6 can be factored as 3 times 2, and none of those are perfect squares. So you got to leave the radical 6 as radical 6, and then the rest, radical 2, well, you cannot do anything with that, and it's all divided by 4. So guys, it's not too difficult. You just have to like see some examples, then practice some on your own, and I think you will be confident with the sum and the difference identities. Guys, this is example 1, and then in my next 2 videos, I'm going to show you a cosine example on cosine and then an example of tangent as well. Okay, thank you guys and take care.